You've probably wondered, or perhaps even worried, what would happen if someone managed to open an airplane door during flight? The image of a sudden catastrophic decompression is a staple in thrillers. But the reality is far more reassuring, and it comes down to a fundamental principle of physics. At cruising altitude, typically around 35,000 feet, the air outside an airplane is incredibly thin, frigid, and contains too little oxygen to sustain human life. This extreme environment demands a solution to keep the passengers safe and comfortable. To make the cabin breathable, it's artificially pressurized to an equivalent of about 8,000 feet above sea level. This vital process creates a stark contrast. A warm, dense, high-pressure environment inside the plane, constantly battling against the thin, low-pressure world just outside the fuselage. The difference in pressure is staggering. Imagine the force this pressure differential exerts on every square inch of the aircraft's skin, especially on a large surface like an emergency exit door. For a typical passenger door, which can measure around 20 square feet, the total force pushing outwards from the cabin interior is immense. It's not just a gentle push. We're talking about a continuous pressure of nearly 8 pounds per square inch, accumulating to well over 24,000 pounds of total force pressing against that door. To put that into perspective, that's roughly the combined weight of two full-sized pickup trucks pushing outwards, trying to burst through that opening. No human, regardless of strength or determination, could ever hope to overcome that kind of insurmountable physical force. This immense pressure isn't a design flaw or a point of weakness. Quite the opposite. It's the very thing that keeps the door sealed shut with unwavering integrity. Airplane passenger doors are ingeniously designed as plug doors. This means the door panel itself is intentionally engineered to be slightly larger than the hole it fills in the fuselage from the inside. When the cabin is pressurized, the higher internal pressure acts upon the entire surface of the door, pushing it firmly outwards. This action wedges the door tightly into its frame, creating an incredibly robust, airtight seal. It works much like a stopper in a bathtub, where the water pressure itself helps to keep the stopper in place. The door can only be opened when it's first pulled inwards or rotated, and then slid or swung away. But with thousands of pounds of pressure continuously pushing it against the frame, any inward movement is completely impossible during flight. This elegant solution is fundamentally different from how a car door or even a house door operates. On the ground, when the aircraft is unpressurized, airplane doors rely on traditional mechanical latches and locking pins to stay closed. These mechanisms are engaged and disengaged by the flight crew. Before takeoff, these mechanical locks are securely fastened. But once the aircraft reaches a certain altitude and the cabin pressurization system activates, those mechanical locks become secondary. The sheer force of the pressure differential takes over, creating an incredibly robust, self-sealing system that far exceeds the strength of any mechanical latch. So even if someone were to somehow try to disable the mechanical locking mechanisms mid-flight, an action that would be an extraordinary challenge in itself due to their secure design and placement, the door would still remain utterly and firmly shut. The laws of physics simply would not allow it to budge. While aircraft are designed with multiple layers of safety in mind, including warning systems for door integrity, the primary safeguard for passenger doors during flight is this elegant and undeniable application of basic atmospheric pressure. Ultimately, the very air you breathe inside the cabin is what keeps you safely sealed within it, making mid-flight door opening an impossibility by design. What other seemingly simple design choices around us leverage fundamental physics in powerful, unseen ways?